We choose to go to the moon.
We have ignition 210. We have a liftoff.
We shall return.
In the summer of 1961, America was losing. The Soviet Union had already shattered every assumption about what was possible in space. They put the first satellite into orbit. They sent the first living creature beyond Earth's atmosphere. And on April 12, 1961, they did the unthinkable. Yuri Gagarin, a 27-year-old Soviet pilot, became the first human being to see Earth from space. He orbited our planet once, just once, and when he returned, the entire geopolitical balance of the Cold War had shifted. America, the nation that prided itself on technological superiority, on being first, on winning, was suddenly, undeniably, in second place. The headlines were brutal. The pressure was suffocating. And in the Oval Office, a young president named John F. Kennedy faced a choice that would define not just his presidency, but the entire trajectory of human exploration for the next 60 years. Kennedy understood something fundamental about the American psyche. We don't just compete, we dominate. We don't just participate in history, we write it. And so, on May 25, 1961, just 43 days after Gagarin's flight, Kennedy stood before a joint session of Congress and made a promise so audacious that even his own advisors thought he'd lost his mind. I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. Think about that for a moment. America had exactly 15 minutes of human spaceflight experience. 15 minutes. Alan Shepard had just completed a suborbital hop 3 weeks earlier. We hadn't orbited anyone. We hadn't docked 2 spacecraft. We hadn't performed a spacewalk. We hadn't even figured out how to keep astronauts alive for more than a few hours in space. And Kennedy just promised the moon, in less than 9 years. But here's what made that promise so powerful. Kennedy didn't frame it as a response to Soviet aggression. He didn't sell it as revenge or catch-up. He sold it as choice. On September 12, 1962, at Rice University in Houston, he delivered what might be the most important speech about exploration ever given. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. That word, choose, carried the weight of American exceptionalism. It said that the future wasn't something that happened to us. It was something we decided. The moon wasn't a Soviet prize to be won. It was a human destination, and America was going to get there first because we chose to, because our engineers would outthink theirs, our factories would outbuild theirs, our astronauts would outfly theirs. This wasn't just a space race. It was a fundamental test of 2 competing visions of human society. And Kennedy was betting everything that democracy, capitalism, and American ingenuity would win. And then he was gone. November 22, 1963, Dallas, a promise left hanging in the air, carried forward by a grieving nation that now had something even more powerful than ambition. They had obligation. Kennedy's death transformed the moon mission from a political goal into a sacred duty. Lyndon Johnson, Kennedy's successor, understood this immediately. He pushed NASA harder, increased the budget until it consumed nearly 4.5% of the entire federal budget. For context, NASA's budget today is less than half of 1%. In the 1960s, America was spending the equivalent of what we'd spend today on a small war, just to get to the moon. The entire industrial might of the nation was mobilized. 400,000 people working for NASA and its contractors, universities churning out aerospace engineers at unprecedented rates. Companies like North American Aviation, Grumman, IBM, and MIT inventing technologies that didn't exist in textbooks yet. They were making it up as they went along. And the risks were staggering. On January 27, 1967, during a routine test of the Apollo 1 capsule, a fire broke out. Gus Grissom, Ed White, and Roger Chaffee were strapped inside, unable to escape. The hatch designed to open inward was impossible to open against the pressure of the flames. They died in 17 seconds, screaming, trapped. The entire nation heard the audio. Congress held hearings. Critics demanded the program be shut down. But NASA didn't quit. They redesigned everything. The hatch, the wiring, the atmosphere inside the capsule. They came back stronger, safer, more determined. because quitting wasn't in the vocabulary of the Apollo generation. 18 months later, Apollo 7 flew successfully. Then came Apollo 8, the mission that changed everything. December 1968. Frank Borman, Jim Lovell, and Bill Anders became the first humans to leave Earth's orbit. They flew to the moon, orbited it 10 times, and on Christmas Eve, they read from the book of Genesis while broadcasting images of Earth rising over the lunar horizon. 1 billion people watched. In that moment, the moon wasn't Soviet or American. It was human. And then, on July 16, 1969, the impossible became real. Apollo 11. Neil Armstrong and Buzz Aldrin landed in the Sea of Tranquility while Michael Collins orbited above. That's one small step for man, one giant leap for mankind. Armstrong's words were transmitted across 240,000 miles of space to 600 million people watching on Earth. America had done it. We'd beaten the Soviets. We'd honored Kennedy's promise. We'd proven that democracy could out-innovate authoritarianism. The celebrations were global: ticker tape parades, presidential medals, stamps and coins and commemorative plates. Armstrong, Aldrin, and Collins became the most famous humans on the planet, but here's what nobody understood at the time. That first landing was just the beginning. Apollo 12 landed 4 months later. Apollo 14, Apollo 15, Apollo 16. Each mission went farther, stayed longer, learned more. The astronauts became geologists, driving rovers across the lunar surface, collecting rocks that would rewrite our understanding of Earth's formation. Apollo 17 launched on December 7, 1972. Commander Eugene Cernan and geologist Harrison Schmitt spent 3 days on the moon. They collected 250 pounds of samples. They drove the lunar rover nearly 22 miles. And when it was time to leave, Cernan stood on the surface one last time and spoke words that still echo today. "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." He climbed the ladder. The ascent engine fired. And for the next 50 years, no human would go that far again. The lunar dust settled behind them, undisturbed. The footprints frozen in time. The American flags planted by 12 astronauts began to fade under the relentless bombardment of solar radiation, bleaching to white ghosts of the red, white, and blue that once flew proudly in the airless silence. Why did we stop? The question haunts us. America had won the race. The political motivation evaporated. The Vietnam War was draining resources and political will. The economy was struggling. NASA's budget was slashed year after year. Apollo 18, 19, and 20 were canceled before they ever launched. The Saturn V rockets, the most powerful machines ever built, were retired and put in museums. The infrastructure that sent us to the moon was dismantled. And an entire generation grew up believing that the moon landings were the peak of human achievement, a summit we'd reached and then retreated from, never to return. But that's not the whole story. Because in those 50 years of silence, something profound was happening. We weren't abandoning space. We were learning how to live there. 1973. Skylab, America's first space station, was launched using a leftover Saturn V astronauts spent months aboard, conducting experiments, studying the effects of long-duration spaceflight on the human body. We learned that bones lose density in microgravity, that muscles atrophy without resistance, that radiation exposure is a constant threat. That psychology matters as much as physiology when you're locked in a tin can with the same people for months at a time. Skylab fell from orbit in 1979, burning up over Australia, but the lessons remained. Then came the space shuttle era. From 1981 to 2011, the shuttle fleet flew 135 missions. It deployed the Hubble Space Telescope, which revolutionized our understanding of the universe. It built the International Space Station, a football field-sized laboratory that's been continuously inhabited since the year 2000. We learned how to dock spacecraft, how to perform spacewalks for hours at a time, how to grow food in orbit, how to recycle water and air, how to cooperate with international partners, turning former Cold War adversaries into essential allies. And while we were learning, the robots were exploring. Mars Pathfinder landed in 1997 with the Sojourner rover, Spirit and Opportunity in 2004, Curiosity in 2012, Perseverance in 2021. We've driven hundreds of miles on another planet. We've analyzed soil and rocks. We've found evidence of ancient water, ancient rivers, ancient lake beds. We've proven that Mars was once warm and wet, potentially habitable. The Voyager probes, launched in 1977, have left the solar system entirely, carrying golden records with sounds and images of Earth into the cosmic void. The Cassini mission spent 13 years studying Saturn, revealing its moons in breathtaking detail, discovering geysers on Enceladus that hint at subsurface oceans. New Horizons flew T Pluto, showing us a world of frozen nitrogen plains and mountains of water ice. This is what 50 years bought us, not abandonment, evolution. We moved from "can we get there?" to "how do we survive there?" From short visits to permanent presence, from competition to cooperation, from the moon as a finish line to the moon as a starting point. And now we're finally ready to go back. Artemis, named after Apollo's twin sister in Greek mythology, the goddess of the moon and the hunt, the Artemis program isn't Apollo 2, it's something fundamentally different. Apollo was 13 missions over 4 years. Artemis is designed to be sustainable, permanent, generational. The first mission, Artemis I, launched in November 2022. Was uncrewed, a test flight of the Space Launch System, the most powerful rocket NASA has built since the Saturn V, and the Orion spacecraft, designed to carry astronauts farther than the International Space Station, farther than low Earth orbit into deep space. Artemis I flew a 25-and-a-half-day mission, orbiting the moon, testing every system, every heat shield tile, every guidance computer. It splashed down in the Pacific Ocean in perfect condition. The systems worked. The rocket worked. The spacecraft worked. And that success gave NASA the green light for Artemis II. Artemis II is the bridge, the necessary, dangerous bridge between the test flight and the landing. Scheduled for launch in April 2026, this mission will carry 4 astronauts on a 10-day journey around the moon and back. No landing, no walking on the surface, just distance, speed, and the ultimate stress test of human spaceflight systems in deep space. The trajectory is called a free return. It's elegant in its simplicity and terrifying in its commitment. The Orion spacecraft will launch atop the Space Launch System from Kennedy Space Center in Florida. The rocket will burn for 8.5 minutes, accelerating the crew to over 17,000 miles per hour. The core stage will separate. The upper stage will fire, pushing Orion and its crew out of Earth's orbit and onto a path toward the moon. This is translunar injection, the moment when gravity's grip loosens and you're committed to the journey. For 3 days, the crew will coast through space, watching Earth shrink behind them. The farther they go, the more alone they become. Communications will take longer. Lightspeed delay means conversations with mission control happen with a perceptible pause. The crew will test every system aboard Orion: life support, navigation, power generation. The spacecraft runs on solar panels, a first for deep space missions. Apollo used fuel cells. Artemis uses the sun, converting photons into electricity with arrays that unfold like wings. They'll test the environmental control system, the technology that keeps the cabin at a livable temperature, removes carbon dioxide from the air, provides clean water. They'll practice emergency procedures. What happens if a meteoroid punctures the hull? What if a solar panel fails? What if someone gets sick? There's no quick abort, no rescue mission. The crew has to solve problems themselves with the tools and training they have. This is deep space. This is the frontier. On the 4th day, they'll reach the moon, but they won't slow down. They won't break into orbit. Instead, they'll use the moon's gravity like a slingshot. The spacecraft will swing around the far side, accelerating, bending its trajectory back toward Earth. At the closest point, they'll be just over 100 kilometers from the lunar surface, close enough to see individual craters, close enough to imagine what it will feel like when Artemis III lands there in 2027. And then they'll be on the far side, the side of the moon that never faces Earth. For 48 minutes, they'll be completely cut off from all communication. No radio signal can penetrate the moon. Mission control will go silent. The crew will be alone with their thoughts, hurtling through space at thousands of miles per hour, trusting that the math is right, that the trajectory is perfect, that they'll emerge on the other side exactly where they're supposed to be. And they will. The moon will sling them back toward Earth, accelerating them even faster. The return journey will take another 3 days. As Earth grows larger in the windows, the crew will prepare for the most dangerous part of the entire mission: re-entry. When Orion hits Earth's atmosphere, it will be traveling at nearly 25,000 miles per hour. That's Mach 32. 32 times the speed of sound. The friction will generate temperatures exceeding 5,000 degrees Fahrenheit, hot enough to melt steel, hot enough to vaporize almost anything. The heat shield, made of a material called avcoat, will ablate, burning away in a controlled manner to dissipate the heat. The spacecraft will glow like a meteor. Inside, the C-RAW will experience G-forces, the deceleration pressing them into their seats. And if everything works, if the heat shield holds, if the parachutes deploy, if the trajectory is perfect, Orion will splash down in the Pacific Ocean, and the crew will be home. But who are they? Who are the 4 people chosen to carry this mission, to risk their lives, to represent humanity's return to deep space? Commander Reed Wiseman, 48 years old, a naval aviator and test pilot with over 2,000 flight hours in more than 30 different aircraft. He's already been to space once, spending 165 days aboard the International Space Station in 2014. He's performed 2 spacewalks. He's commanded the station's robotic arm. He's lived in the void and thrived there. Wiseman is calm under pressure, analytical, a leader who inspires confidence. He'll be the one making the critical decisions if something goes wrong. He'll be the one the crew looks to when fear creeps in. Pilot Victor Glover, 48 years old, a Navy commander and FA-18 pilot with 3,000 flight hours and 400 carrier landings. He flew Artemis's predecessor mission, SpaceX's Crew 1 to the International Space Station, spending 168 days in orbit. Glover is also the first African-American astronaut assigned to a lunar mission. He carries with him the legacy of pioneers like Ed Dwight, who trained to be an astronaut in the 1960s but was passed over. Of Robert Lawrence, the first black astronaut who died in a training accident before he could fly. Of Guion Bluford, who became the first African-American in space in 1983. Glover's presence on Artemis II is a statement. It says that space is for everyone, that the stars don't belong to one race, one nation, one gender. They belong to all of us. Mission Specialist Christina Koch, 45 years old, an electrical engineer who holds the record for the longest single spaceflight by a woman, 328 days aboard the International Space Station. She's performed 6 spacewalks, including the first all-female spacewalk with Jessica Meir. Before NASA, Koch spent a year at the Amundsen Scott South Pole Station in Antarctica, one of the most isolated places on Earth, where temperatures drop to -100 degrees and the sun doesn't rise for 6 months. She knows isolation. She knows endurance. She knows what it's like to be cut off from the rest of humanity with only a small team to rely on. Koch will be the first woman to travel to the moon. She'll be the bridge to Artemis III, when NASA plans to land the first woman and first person of color on the lunar surface. Mission Specialist Jeremy Hansen, 48 years old, a colonel in the Royal Canadian Air Force and a CF-18 fighter pilot. He'll be the first Canadian to travel beyond low Earth orbit, representing the international partnership that makes Artemis possible. Canada is contributing the Canadarm3 to the Lunar Gateway, the space station that will orbit the moon and serve as a staging point for surface missions. Hansen's inclusion is a reminder that while NASA leads Artemis, the program is built on collaboration. The European Space Agency is providing the service module that powers and propels Orion. Japan is contributing life support systems and rover technology. This isn't America going back to the moon alone. This is humanity going back together. These 4 will spend 10 days together in a capsule about as spacious as an SUV. They'll eat freeze-dried food. They'll sleep in shifts. They'll use a waste management system that's essentially a high-tech toilet in a closet. There's no privacy, no escape, no moment where you can just step outside for fresh air. The psychological challenge is as real as the physical one. NASA has studied this extensively. The agency knows that crew compatibility can make or break a mission. They've trained together for years, building trust, learning each other's communication styles, practicing for emergencies until the procedures are muscle memory. Because in deep space, hesitation kills, confusion kills, panic kills. The only thing that saves you is training, teamwork, and the absolute confidence that the person next to you knows exactly what to do. And if they succeed, if Artemis II completes its mission and returns safely, the next step is Artemis III. Currently planned for 2027, this mission will land astronauts on the moon's South Pole, a region that's never been visited. Why the South Pole? because that's where the water is. Apollo landed near the lunar equator, where the sun shines directly and temperatures swing from boiling to freezing. The South Pole is different. There are craters there that haven't seen sunlight in billions of years. They're cold traps, so cold that water ice has accumulated in the shadows, protected from the sun's heat. NASA's Lunar Reconnaissance Orbit. R has confirmed it. There are billions of tons of water ice at the moon's poles, and water is everything. You can drink it. You can split it into hydrogen and oxygen and breathe it. You can use the hydrogen as rocket fuel. Water on the moon means we don't have to carry everything from Earth. It means we can refuel spacecraft in lunar orbit. It means we can support a permanent base. It means the moon becomes a gas station, a supply depot, a jumping-off point for the rest of the solar system. Artemis III will use a lunar lander built by SpaceX, a modified version of their Starship vehicle. It's massive, over 50 meters tall, capable of carrying tons of cargo and crew to the surface. The astronauts will spend about a week on the moon, far longer than any Apollo mission. They'll set up the first components of a lunar base. They'll drill into the ice and extract samples. They'll test technologies for living off the land, for in situ resource utilization, the fancy term for using what's already there instead of shipping it from Earth. And when they leave, they won't be the last. Artemis IV, V, VI, and beyond are already being planned. Each mission will add more infrastructure, more habitats, more power systems, more science experiments. The Lunar Gateway will be assembled in orbit around the moon, a small space station where crews can live for months at a time. It will serve as a hub, a place to dock Orion and the lunar landers, a base camp in space. The Gateway is modular, designed to be expanded over time. It will have living quarters, science labs, docking ports, solar arrays, and a robotic arm. Crews will rotate through, some descending to the surface, others conducting research in orbit, studying the moon's geology, its exosphere, its interaction with the solar wind. The Gateway will also serve as a platform for telescopes, observing the universe from a stable orbit without Earth's atmosphere interfering. And critically, it will be the testbed for the technologies we need for Mars. Life support systems, radiation shielding, closed-loop water recycling, food production. All of it will be tested at the moon before we risk it on a 2-year mission to Mars. Because that's the ultimate goal. Mars, the moon is the proving ground, but Mars is the destination. It's the only other planet in the solar system where humans could potentially survive. It has an atmosphere, thin but real. It has polar ice caps. It has a 24-hour day, almost identical to Earth's. It has seasons. It has geology that suggests it once had rivers, lakes, maybe even oceans. If life ever existed anywhere beyond Earth, Mars is the most likely place we'll find it. Or evidence of it: fossil microbes in ancient rocks, chemical signatures in the soil, subsurface water where life might still cling to existence. The discovery of life on Mars, even extinct life, would be the most profound scientific finding in human history. It would answer the oldest question we have: are we alone? But getting to Mars is exponentially harder than getting to the moon. The moon is 3 days away. Mars is 6 to 9 months, depending on the alignment of the planets. You can only launch during specific windows when Earth and Mars are positioned correctly, and those windows open every 26 months. If you miss it, you wait. Once you're there, you can't just turn around and come home. You have to wait for the planets to align again, meaning a Mars mission is a minimum 2.5-year commitment. The astronauts will face cosmic radiation for the entire journey, far beyond Earth's protective magnetic field. They'll face bone loss, muscle atrophy, vision problems caused by fluid shifts in microgravity. They'll face isolation on a scale humans have never experienced. At its farthest, Mars is over 200 million miles from Earth. A radio signal takes over 20 minutes each way. You can't have a conversation with mission control. You can't ask for help and get an immediate response. The crew has to be self-sufficient, capable of solving any problem that arises with only the resources they brought with them. This is why the moon matters. Every challenge we face on Mars exists in some form at the moon. Radiation: the moon has no magnetic field, no atmosphere. Astronauts there will face radiation levels similar to deep space. Isolation: a lunar base will be farther from help than anything on Earth. Resource scarcity: everything on the moon has to be built, grown, or extracted from the regolith. The moon is our classroom, our laboratory. our final exam before we attempt the test that will define our generation. And if we pass, if we can live and work on the moon for months or years at a time, then Mars is within reach. And if Mars is within reach, then the moons of Jupiter and Saturn, the asteroids, the outer solar system, all of it becomes possible. This is the vision of Artemis, not a single mission, not a political stunt, but the foundation of a spacefarer. G-civilization. A civilization that doesn't put all its eggs in one planetary basket, because here's the uncomfortable truth: Earth won't last forever, not in a form that can support human life. In about 1 billion years, the sun will heat up enough to boil Earth's oceans. In 5 billion years, it will expand into a red giant and consume the inner planets entirely. Long before that, we'll face existential threats: asteroid impacts, supervolcano eruptions, pandemics, climate change, nuclear war. The list is long and terrifying. And while we should absolutely do everything we can to protect and preserve Earth, to be good stewards of the only home we've ever known, we also have to acknowledge the possibility that our survival as a species might require a backup plan. A second home. A foothold on another world. That's what Artemis is really about. It's about insurance. It's about the long-term survival of humanity. It's about refusing to accept that we're stuck on this one fragile planet, in this one fragile solar system, in this one fragile corner of the galaxy. It's about the audacity to believe that we were meant for more. That our destiny isn't to live and die within the same gravitational well where we were born, but to spread outward, to adapt, to evolve, to become something greater than we are. And it starts with 4 people on a 10-day mission around the moon. 4 people who will travel farther from Earth than anyone has in over 50 years. 4 people who will test the systems, prove the concept, and pave the way for everyone who comes after. When Artemis II launches, it won't just be a rocket leaving Earth. It will be a statement that the silence is over, that the 50-year pause has ended, that humanity is ready to take the next step. And when that crew returns, when they splash down in the Pacific and step onto the deck of the recovery ship, they'll carry with them the knowledge that we can do this, that the technology works, that the dream is real. And the world will watch, just like they watched Apollo 11, and they'll remember what it feels like to be part of something bigger than themselves, to witness history, to believe in the future, because that's what space exploration does. It reminds us that we're capable of incredible things when we work together, when we set aside our differences and focus on a common goal. When we choose to do the hard things, not because they're easy, but because they're worth it. 50 years ago, we went to the moon to prove we could. Now we're going back to prove we can stay, and after that, the stars, because America doesn't just make history, we build the future. And the future begins now.